Sometimes we need the large language model to ask us questions, to really guide the process of solving some problem that we have or helping us obtain an answer or an output that we need. And we may not know what are all the steps to achieve that goal. And so what we'd really like to do is we'd have to have the large language model ask us questions. So whenever we want the large language model to ask us questions, the pattern that we can use is called flipped interaction. And so the idea behind this is rather than, we're going to flip the interaction rather than us providing questions and the large language model providing answers, we're going to flip that and we're going to have the large language model ask us questions and we're going to provide the answers. And we can do this in a number of different ways. We can do this to play games. We can do this in order to try to reach some goal. Like the large language model keeps asking us questions until it gets enough information to achieve some goal. There's a variety of different ways that you can use this, but this is incredibly helpful when you don't necessarily know everything that's needed, or if you want to be tested or quizzed on something, anywhere where you don't want to be in the driver's seat. You want to really be helping provide information, but you don't want to be formulating the questions or tasks. So let's take a look at an example of the flipped interaction pattern. So the key to this is we start off by asking the large language model to ask me questions. And then we give it some topic that we're going to have it ask questions on. So ask me questions about fitness goals until you have enough information to suggest a strength training regimen for me. When you have enough information, show me the strength training regimen. Ask me the first question. Now this is the basic pattern, is you say ask me questions on a particular topic, and then it's more helpful usually if you give some goal. Why are you asking the questions? Are you trying to have it quiz you? Or are you trying to get a fitness regime like we're in this one and have a fitness plan? Like what is it you're trying to achieve? And the more information, the more context you can give about what you're trying to achieve, the better questions it'll be able to ask you. Now, other things you can do are you can tell it how many questions to ask you, how many questions to ask at a time, a variety of different things. But one really handy thing you can do is end the flipped interaction prompt with ask me the first question. So one thing that you often want to do is do it one question at a time. Now sometimes you'd like to have like 10 questions listed and you can answer them, 1, here's my answer, 2, here's my answer, 3, here's my answer. And you can certainly do it that way if you want to get it all at once and think about it all at once. But a lot of times I like to do it one question at a time. And so if you want to get that one question at a time behavior, usually a really reliable way of doing that is to say, ask me the first question at the end of the prompt. So we're going to generate this fitness plan. So we say, ask me the first question. And it says, great, let's get started. My first question is, what are your specific fitness goals? Are you looking to build muscle mass, increase strength, endurance, performance, or achieve a particular goal? And I go on to say, I'm looking to build explosive power and also prevent patellar tendinopathy from doing jumps on a mountain bike. Now, I don't know if this is a correct pronunciation of patellar tendinopathy, but this is what I've sort of looked up as I've started to experience some pain in my knees at certain times when I've been doing a lot of jumps on a mountain bike. And so I looked it up and this seems to be the reason for it. And so I'm providing that information because I don't necessarily know. Well, actually I do know because that's part of the reason I picked this one is I could fact check it a little bit against what I've read on the internet. But I wanted to generate a fitness regime for me. And this is something that I've actually been doing, is figuring out what exercises I should do to help out, my knee and strengthen so it doesn't happen again. And then it asks, do you have any current or past medical conditions or injuries that may affect your ability to participate? Additionally, have you been diagnosed with this, or are you looking to prevent it proactively? And I give it some information. And then it goes on and it asks me how many days per week I can dedicate. And additionally, do you have any access to a gym or fitness equipment? I'm specifying I can work out 5 days per week for 30 to 45 minutes at a time. And then we finally get to the point where it actually generates a full sort of fitness regime for me of what I'm going to do to work on this. Now, what's really interesting is it's gone through and it's taken into account the answers from my earlier questions. And I know that because I've been looking for what are good exercises to help work on this issue with my knee that I've been having. And these are exactly the types of things that you see recommended, like the goblet squat. The split squat is one that you see a lot of times. A lot of different types of squats and things are very helpful, and these are the types of things that I see. But it's also taken the overall context that I'm looking for, weight training. It's gone and generated the entire weight training regime. Now notice at the very beginning, I said when you have enough information. So I said, show me the strength training regime. And so this kind of shows another important sort of power of this prompt pattern, this flipped interaction pattern, is we give it what we're trying to achieve, and how much it should ask you. And basically we set the goal as ask me enough until you have enough information to show me the training. And so it asks questions until it thinks it has enough information and then generates the output. Now, sometimes what you'll see when you ask questions to a large language model is it'll tell you, well, in order to do this well, I'd need to get a bunch of additional information. Or it might generate a generic initial, plan and then say, but if you provide additional details to me, I might also be able to do blah, blah, blah. And so what we see here is this is kind of getting rid of all that. Let's skip that step of getting something generic or being told that there's not quite enough information, you need to answer questions for us, and let's just say, go ahead and ask us the questions that you need until you get there. Now, this can also be used for doing other things like quizzing, playing games, anywhere where we want to have knowledge in the large language model drive the creation of the questions. And this is really helpful when it has theoretically or been trained on knowledge or patterns in language that will be useful in creating the questions and are things that we don't possess ourselves. So whenever that's the case, it can probably go and more effectively think up questions. So if we say, okay, I need a fitness regime and I have patellar tendinopathy, I may not know, what are the types of questions that you should ask somebody who has this. I may not know what are the types of exercises that are commonly discussed if you have this condition, but it has been trained and seen patterns of language where when people were discussing this particular condition, these are the exercises that were discussed. These were the additional questions that were asked in order to select exercises. And it has access to those patterns from its training data that then help it to select good questions to design that appropriate training plan. So whenever you need the large language model to ask you the questions, or you can think about a customer service example where you're trying to diagnose some problem that a customer has, or automate some response, and you need to collect information and then take action, the flipped interaction pattern is a really powerful prompt pattern to use to do that. Large language models, as powerful as they are, they can't do everything on their own. They're going to have to reach out into other data sources, and they're going to have to learn how to use other tools to be really effective over time. So one of the things we have to learn how to do is build prompts that can allow the large language model to essentially reach in and query new information, to use other tools that can help it do reasoning or computations that it fundamentally is not designed to do. And so how do we go about doing that? So one way of doing that is with an approach called React. So the idea behind this is that we want to teach essentially the large language model how to think through a process and understand steps where it needs to go and use some other tool, to take some other action outside of it and get the result of that tool and bring it back in as some type of computation or result that it can then incorporate. And so there's a specific way of writing prompts to do this. Now, this is similar to chain of thought prompting like we saw before. We're going to use some of those same concepts from chain of thought prompting, but we're going to expand the approach to have this concept of certain things that the large language model knows it needs to use some external tool to perform. So let's take a look at this. Now bear with me because this is a longer example. We're going to do a single example that we're going to teach the language model with, and then we're going to ask it to perform the same task. So in this example, we have a task which is calculate when I need to arrive at the Music City BMX national race for my son to be on time for his 9 to 10 open race. So BMX is a bicycle racing sport. Some of my examples lately have been around BMX. And Music City BMX is a local BMX track here in Nashville that hosts one of the big national races for BMX racing. And so one of the things is I need to figure out, when do I need to show up at the track? Because these are all-day, multi-day events, and sometimes you may want to figure out, how late can I sleep before getting in the car and driving then in order to arrive? And what happens is, in these races, you have hundreds of individual little races that are essentially like 30 seconds each. These are called motos that are run, and you want to figure out, when you're moto 87, for example, well, how long do I need to wait after the start before that race is going to start? And so sometimes there's a balance there of trying to figure out, when do I need to be at the track actually, as opposed to when does the race start? And so what we're going to do is we're going to have it solve this problem for us. We're going to pretend to solve this problem. This isn't actually solving it, but we're going to show you how this process works. So we give it a task and we give it an example, which is calculate when I need to arrive at the Music City BMX national race for my son to arrive on time for his 9 to 10 open race. And then we say, think. I need to find out what time the first race begins. I can use a web search of the Music City BMX site to get that information. So remember, this is our example. So we're saying, here's the thought process. I need to first figure out the first step. Now you remember back to chain of thought where we're trying to have it explain its reasoning? Well, we're kind of doing the same thing. We're explaining the reasoning behind it. So we're saying, I need to find out what time the first race begins. We're explaining what we're trying to do. I can use a web search of the Music City BMX site to get that information. And then we have the next thing we do, which we say action, search, and then we give the Music City BMX website. And so action here in the search is basically a tool that it's learning to use. It's learning to use some external tool, in this case a web search. So it knows that there's certain information it does not have, and so we're teaching it, when you need information that you don't have, go and search for it, and you can search for it with a website. And then it says the result, we tell it, is all races start at 9 a.m. So then we say, think. I need to find out how many motos run before the 9 to 10 open race. Motos are essentially the individual races that are going to run before that race. I can use a web search of the Music City BMX site to get that information. And then we show it again, another example of searching, assuming there's a search tool available to it, for the Music City BMX site. And then result, we show it the result. There are 30 motos that run before the 9 to 10 open race. And then we say, think. I need to find out how long each moto took last year. I can use the video live stream from the USA BMX website and record how long the first 10 motos took. And then we say action, video, and we give it some fake video and pretend that, hey, we were able to go and pull this video down and time something. And then result, the first 10 motos took 5 minutes. Think, if 10 motos took 5 minutes, 30 motos will take 15 minutes. The race starts at 9 a.m., so I need to arrive before 9:15 a.m. when the race starts. I will arrive 30 minutes early at 8:45 a.m. to be safe. So remember, this is our faux example. We've kind of imagined a scenario where I need to solve this problem, and I'm using a series of web searches and then watching a video from a prior year to figure out how long things took, and I'm trying to teach the large language model, in this case ChatGPT, to use these same tools to solve the problem. So then I ask it, here's the new task. Calculate what time my 36 to 40 novice race will end at the USA BMX Grand Nationals. And then I say, think, to prompt it to start thinking what is the next step. And you'll notice what it does. It then says, I need to find out what time the first race begins at the USA BMX Grand Nationals. I can use a web search of the USA BMX site to get the information. Action, search, USA BMX Events Grand. So notice it's picked up on a couple of things. It's picked up on the idea that it has this tool called search that it can use to go and pull in information. You'll notice it's also picked up on the format of the URL. Now, this format I had was just completely fictitious in this example, but it's picked up that, oh, there must be this formatting, there must be a pattern behind these URLs that I can use, so I can go and search and use some knowledge of the structure of those URLs to pull in the right information. So it's learned essentially how to go into a web search. And then it says result, note, as an AI language model, I'm unordered to perform web searches. Please assume a hypothetical result of the purpose of this exercise. The first race begins at 8 a.m. Now what's interesting here is if we were actually integrating this into a real system, we could have the system, whenever it sees a result, stop, pull in the actual result, put it in there, and then basically feed this first chunk back to the language model to then continue the process. So we don't actually have to worry about if it's going to fake the rest of this. We could just have it go, and we could incrementally get to each time we get a new result out that we actually need to fill in, we could go and run the web search and fill in that result. It then keeps going. It says, I need to find out how many motos run before the 36 to 40 novice race at BMX Grand Nationals. I can search, and it goes and searches on the grands, and then it has a hypothetical result. There are 120 motos. Goes and thinks again. I need to find out how long each moto took last year. I can use the video live stream, and then it picked up on the URL pattern. So you notice it's learning a lot of things. It's learning how to use the tool and how to input data in a particular format for it based on what I showed. It then says, okay, here's the result from that. And then it says, think, if 10 motos took 6 minutes each, or took 6 minutes, then each moto took an average of 0.6 minutes. Therefore, 120 motos will take approximately 72 minutes. The first race starts at 8 a.m., so the 36 to 40 novice race will start around 9:12 a.m. I need to find out how long the 36 novice race itself will take. And it goes and does that, and then it says if the 36 to novice race starts around 9:12, then it will end around 9:15. This is the approximate time my race will end at the USA BMX Nationals. And so what's interesting is that it actually ended up in the end getting slightly off track. It gave me the begin and end, so it's telling me the begin time, but it also went and calculated the end time, which I may or may not want. But the more important thing is that along the way, it followed my pattern. Up here, I taught it this concept of searching. So I had action search, musiccitybmx.com. I had another action search for musiccitybmx.com. I had an action video right here. And it learned how to use these tools, and then it's applying the exact same tools down here. It's applying search, it applies it again, then it applies video, and it's applying it using the format. So you can imagine it's essentially learning to, run a web search, to watch a video, but again, these are tools, so it could basically go and send some information off to the tool, get an answer back, and then pick up in its reasoning. Now, the way that we would do this is we would have to have a way, if we're going to use this, to actually, when it gets to the point where it says, here's what I'm going to do, we would stop it and go give that data to the real tool, get the answer, and then come put it in for the result. And then we would feed this whole thing back in with the correct answer as the prompt. It then hopefully will run through up until it gets another action, in which case we would go and get the real result from that tool, put it into the prompt, and continue. And we would continue down until we got to a point where we had an output. Now, a better way of doing this would be to have some, way of it saying, okay, I'm done, and I should have put that into the prompt here. But this is doing basically, it's teaching it, here are some tools that you can use if you use this format. So you can go and run this particular tool, and you describe the tool to it. Now, other ways to do this, you can also, if I didn't have every tool used, I could have edited this prompt and I could have had a description of each tool and the format and other information that it could use to help it figure out which tool to use. Now, in my simple example, I did it just based on giving it patterns that I had directly in the sort of the few shot examples that I provided. But you can also have other ways of sort of catalogs of tools and their descriptions, so it can think about which ones to use at the appropriate time. And you see how it's beginning to reason and know, which tool do I need to use at which point in time to get which type of information. So you can teach it to do this sort of problem solving, so you can go and integrate it with other tools, and you can build these prompts that allow it to tap into other tools. And you see this in a variety of different frameworks. There's a tool you may have heard about called LangChain, which is a framework for writing these types of automation processes. And they use React underneath the hood in order to be able to go and do some of the interesting things like this that they do. Sometimes we know part of the solution that we need when we're working with a large language model. So we have a problem and we know some of the steps or some of the pieces that we want involved in the solution, but we don't know the full solution. And what we need is the large language model to help us fill in the blanks, to put together the missing steps, basically to complete the recipe. Give us the detailed set of steps that take the ingredients that we have or the bits of information we know about how to cook this particular dish and fills in all of the gaps. And so the recipe pattern is a pattern for doing this. We give the large language model some goal that we're trying to achieve, and we give it the parcel set of steps that we know that we're going to have to involve in creating the overall sort of solution, the recipe, the goal, whatever it is. We're going to give it part of what's needed and ask it to fill in the rest. So this is really a way of getting the large language model to help us fill in our gaps in a process or gaps in our knowledge about a series of steps that need to be taken. So the recipe pattern can be really useful. And I'm also going to show you that our sort of intuitive shorthand for describing gaps and ways that we talk about things that we know are part of a process or part of a series of steps, but we don't know the exact details, that our intuitive way of expressing that is actually something that the large language models like ChatGPT can understand. So let's take a look at an example of this. So we're going to say we're going to add a feature. So we're going back to our trip planning application. And we're going to say, I will tell you my start and end destination, and you will provide a complete list of stops for me, including places to stop between my start and destination. So notice what we're doing is we're providing essentially an incomplete recipe. We're saying, here's where I'm going to start, here's where I'm going to get to, but I need to know what goes in between. And it goes back and it takes one of our prior examples of going from, or actually it creates its own example of traveling from Nashville to Atlanta, and notices that you're going to go through Chattanooga on the way, which is true. If you're going to drive from Nashville to Atlanta, you're probably going to drive through Chattanooga, and it suggests things that you could do, like going to the Tennessee Aquarium in Chattanooga or Lookout Mountain. So where it gets interesting is, if you remember back to the trip planning application, I taught it my own language for describing my trips. And so I used the meta language creation pattern. Now I'm going to combine the meta language creation pattern and the recipe pattern to do something interesting. So what I'm going to do is I'm going to say Nashville, 0. So I'm starting in Nashville, and then I'm going to have just dots or ellipses, basically ... arrow, ... arrow, Fairhope, Alabama, 2. So I'm going from Nashville to Fairhope, Alabama, and basically what I'm signaling to the model is, I want you to complete it. Tell me where to stop in between, and I'm indicating I want to stop twice. I'm willing to make 2 stops in between, but I don't know where. You fill in the recipe that gets me from Nashville to Fairhope and has 2 stops in between. And it understands this. So dots are obviously ... is a natural way that we can express something we don't know. It understands that, and it fills in the recipe. It says we're going to start in Nashville, Tennessee, no time spent, as per your request. I highly recommend spending time in Nashville, Tennessee. I live here, so all of my trips start with not staying in Nashville, because I'm always here. Well, not always, but a lot of the time. And then it fills in the 2 stops for us. It fills in Birmingham, Alabama, and Montgomery, Alabama, which are both between Nashville and Fairhope if you take the most direct route, and then the end is going to be Fairhope, Alabama. So you notice it's basically understood the constraints that we placed on it. We said Nashville, 0, arrow, and so we're using our language. We're just defining the starting point. We're then saying ... meaning this is something I don't know. It's a blank spot in my template or my recipe. So you need to fill in this recipe with where we should stop here, and then arrow ... and I'm saying here's another blank spot where I don't know what should go here in the recipe, fill it in, and then arrow Fairhope, Alabama. And so it's gone and we're using the recipe pattern here to get ChatGPT or another large language model to complete our request. And if we went and we did this again, so if we said, LA, and let's just do 1, and then we said ... and we'll see how it interprets this, because I think it's unclear to me what it even means. And then we said we're going to go to New York. Let's see what it interprets this as. And so it now starts giving us a trip saying, okay, here's where you're going to start. Los Angeles one day, then you're going to go to Las Vegas, Grand Canyon, Santa Fe. I'm curious if it'll, how many stops it's going to have. So you notice that when I did this one, I had 4 placeholders here. I'm getting more than 4 placeholders in between, because I kind of expressed that I wasn't really sure. Like, I don't have ... arrow, ... arrow, and then I'm there. I just have a whole bunch of dots, which is much more indefinite, which is exactly what I wanted it to do, interestingly enough, and I didn't know if it was going to get there. But I was basically expressing, I'm going to go from LA to New York. I'm going to have a bunch of stops in between. I don't know what they should be. Plan my trip for me. Here's how long I'm going to stay in LA. Here's how long I'm going to stay in New York. And everybody can argue with how long I'm spending in each place. They're all wonderful places, but it interprets the missing pieces of my recipe. It probably also knows that I'm going to need quite a few stops if I'm going to make this a leisurely drive from Los Angeles to New York, and it fills in a whole bunch of different places that I could potentially stop along the way in order to have an interesting trip from Los Angeles to New York if I run a very long road trip as a vacation. And so this shows you how the recipe pattern works. You give the large language model the goal that you're trying to achieve, the pieces that you know need to fit into the solution, or the steps that have to be there and where they're going to be placed. And then you ask it to fill in the rest. And you can use ellipses or other types of things to indicate places where you don't know what's going to be there and you want it to fill it in. And it'll go and complete the recipe for you using the recipe pattern. We've heard over and over in the news that these large language models make all kinds of mistakes and can lie to you, and they'll never admit their mistakes in the first place, and they'll keep telling you they're right and produce weird outputs. And of course, this fundamentally kind of misses the point of the tool. These aren't meant to be tools for answering questions necessarily. Now, sometimes they can answer questions and do it very accurately. And sometimes they produce things that look like answers but aren't actually accurate. And so as long as we understand they're really for generating text, and sometimes the text they generate can answer things for us correctly, and sometimes it's going to make mistakes, as long as we realize that, we can use these tools effectively. Now, one thing we can do is we can use prompts to support us in our identification of what are the facts that the tool is putting into its output and which of those facts really matter. And we can go and then follow up on them and check them. Now, one of the things that happens sometimes when we're working with output from these tools is that because the output looks so realistic, so human, so convincing, we assume that it's true. And when it's producing large volumes of text, it can be hard to spot all the different assumptions and facts that are baked into the text that we really need to follow up on and fact check. Anything you get out of one of these models, you need to take ownership of and make sure that you've checked it thoroughly and really believe it. What do we do to support us in this effort of trying to make sure the output is correct and factual? Well, we can use the fact checklist pattern to help us figure out what facts are actually in the output and need to be followed up on. So I'm going to give you an example of this. So I've taken our outline expansion tool. And if you remember, we used a couple of different patterns, including the menu actions pattern. We used the outline expansion pattern. We had several different capabilities. One of the things we could do is we could go and expand the outline. We also added the ability to be able to generate text for any bullet in the outline. And we can generate for a number of items. And we had a whole menu system to be able to do this. Now, one of the things we'd like to be able to do is when we do generate text for part of the outline, I'd like to know what I need to follow up on and fact check at that point in order to make sure that I don't present information that's inaccurate. So if we look at this, the way that we can do this is with the fact checklist pattern. We say, whenever you output text, generate a set of facts that are contained in the output. The set of facts should be inserted at the end of the output, and you could put them wherever you want. I'm just putting them at the end. The set of facts should be fundamental facts that could undermine the veracity of the output if any of them are correct. So I'm setting up a new set of instructions for the large language model that says, anytime you produce text, give me the corresponding set of facts that the text depends on. And that's the way I can go and follow up on them and check them. And so it says it understands. And so now I'm going to use our outline expansion program that we've written. I'm going to tell it to write a paragraph for section 3.5.2.2. So this section is considerations for choosing the appropriate style, and it generates a whole paragraph of text for me. And then what it does is it generates a set of fundamental facts down here that are the facts that are contained within the paragraph. And so the facts are, for example, writing style can range from technical to creative to instructional. There are other things like instructional content may adopt a clear and step-by-step style. Now this paragraph that I chose for it to write, it has a lot of different facts that maybe they're correct, maybe they're not, but it's not something that I have to worry as much about going and extracting and just staring at text, because I now have a list of things to follow up on. At a minimum, I need to look at this list and follow up on these items, or just actually visually check them myself for my own knowledge. That's sort of the minimum level. Now I have a minimum bar. At least these things I need to go and follow up on, and it's sort of flagging to me, here are some things that you need to go and check. The other thing I can do is I can compare this list to the paragraph up here. So any person that's probably using one of these tools can compare, here's the list of facts below, here's the actual text above. Is the list of facts complete? Are there statements in the text above that are missing below? And if there are, those are probably things that I would want to go and follow up on as well. And so by checking and comparing the two lists, one, we can see, is it really fully extracting all of the facts that are important? And that in itself will clue us into and make us think through, what is this really saying and what are the fundamental facts to it? So just the sort of the action of going and comparing the facts to the text it's produced will help us get us into the mode of thinking through the correctness of what it's produced. The next thing I can do is I have a minimum bar. At least I need to go and check up. At the very minimum, I need to go and check the list of facts that it produced and follow up and make sure that they are correct. And if any of them is incorrect, then probably there's an error in the text above. And then if I notice that there's something in the text above through this comparison that's also not present in the facts, I could add that to my list and go check it. So this is a tool that can help us, get into the mode of fact checking the output. It may be correct, but we still don't know for sure until we actually fully follow up on it. And this gives us some tools to help us, one, know that there are things to follow up on, at least follow up on these things, and then two, to help us give us a tool that we can go and compare to what it produced to see, is the minimum list of things that I followed up on good enough, or are there all other things that are in that text that maybe I should think through or follow up on? Now, it doesn't guarantee that we're going to come up with the right answer. We might think that it's still accurate when it's not. Even if we follow up on those facts, there may be some hidden assumptions, but it's much better than if we just read a bunch of text with no sort of support or stimulus to think through the fact-checking process. So the fact checklist pattern is something that helps us get us into the mode of checking the output, checking its veracity, and having a format that makes it easier for us to sort of extract and compare the information and the sets of facts with what's really true using other external sources.